All right, so today we're looking into doing the introduction to transition matrices. So transition matrices, what they've done is they've collected a lot of data and they sort of look at, what the data starts to show us, sort of, patterns. So then they create these transition matrices that are used to predict what will happen in the future according to what's previously happened. And they show the possibility. So it's not dead set, but it says, because we're using facts of other thing from the past, it's a good indication. So companies they want to use this information to predict, so they might be, so that they know. So say for example, they need so many workers when in the future for next month, so they might be using things like this to calculate it. So we've got a few things we need to know about transition matrices. So transition matrices, firstly, they are always square matrices. So what do I mean by that? They have the same number of rows and columns. So, a 3 by 3, a 2 by 2. So they're always square matrices. And what we do, because we're using to predict things with it, they often talk about percentages, but it's not actually percentages written in the matrix, it's decimals. So we're going to write that down, that percentages are written as decimals. So you got to be careful with this. So let's just have in our example. So example 20, if they say something about 20%, that would equal 0.20 in your transition matrix. Now, another fact about transition matrices is the columns. So remember, they're that going that way. The columns add up to 1. Okay, so if you had all those decimals there, they're going to add up to 1. Okay, that's in a transition matrix. And the last one that we might write is they often indicate the transition matrix with is labeled with a capital T. So sometimes, because you don't want to keep writing it out all the time, so you're going to write it with a capital T like that, on your notes to show you how you're doing it. All right, so a transition diagram. So suppose that in a certain town you have 2 choices of an activity on a Saturday night, either going to the movies or staying home. So suppose further that it has been established. So this is where I'm saying they get out some stats. They've seen what's happened. And they say that 20% of the people who go to the movies this Saturday, will go to the movies again next Saturday. And 80% of those who go to the movies this Saturday will stay home the next Saturday. And then they had the other stat, 40% of the people who stayed home this Saturday, they will go to the movies next one. So you can see what we've got is we've got this diagram which shows that. So if you look at this one, it says 20% of those who go to the movie will go again next Saturday. So can you see where we've got movies, movie to movie, the arrow is 20%. And then if we look at the next one, and they said 80% of people who go to the movies this Saturday will stay home next Saturday. So you can see 80% who were at the movies go to stay at home next Saturday. All right, and then if we look here, we've got 40% of the people who stay home this Saturday will go to the movies. So you stayed home, the next time you go to the movies. And then our last one is 60% of those who stayed home stay home again next Saturday. So S to S. Okay, so that's a transition diagram because it's telling you how it all moves. So in this case, there's only 2 scenarios or 2 things that are happening. You're either going to the movies, which is the M, or you're staying home which is the S. So let's just write so that you know M was you're going to the movies and S equaled stay home, because this is what we're going to change this into a transition matrix. Now, because there is two options there, movies and stay home, our transition matrix is going to be a 2 by 2, isn't it? So because remember I said they're always square, so there's this is a square matrix and a 2 by 2 because there's two options. Okay, so what we have to be careful with is how we write it. If we write, see how we wrote M movies first and then S along here. So when we look across the top, this is what you're there at this Saturday. And then when you see it goes MS. So the same order is going across there. So maybe just write a little note there. It's the same order, meaning M to S. Yeah. All right. So that's important. You need to have it like that. So then when we're setting up the transition matrix, I'm going to show you with those what I highlighted it there. So when we were on movie this Saturday and then movie the next Saturday, so M to M was 20%. So what I'm going to change, I'm not going to write it as a percentage. I'm going to write it as a decimal. So it's 0.2. Okay. Then if you looked at, it's often easier to do the ones going to itself. So if you look at, say, this S to S was 60%. So I look for the S to S spot, which is 60%. Now, if we add in those other ones, so if in the green, it was from movies, and then the next week they stayed at home was 80%. So I changed that to 80. 0.8, sorry. And then the next one, stay at home but go to the movies the following week was 0.4. So if you have a look at those numbers, you can see that they total up to 1. Do they not? Yeah. And so that was that little fact we said up the top, that the columns are going to add up to 1. So maybe just write it in there so that you remember columns add up to 1. Okay, so that's how we change a transition diagram into a transition matrix. So you can get us to do that. And so we're just going to start off with this, and we'll use these transition matrices to predict in the future, but that will be in a few lessons time. At the moment, we're just going to practice setting these up. So let's have a look at this one. An amusement park has 2 rides for preschool schools, and these are the Ferris wheel and the merry-go-round. So they're calling F for Ferris wheel and M for merry-go-round. After each ride, children can choose which ride they want to go on next, and the park observes the following things. So that 70% of the children on the Ferris wheel go on the Ferris wheel again, and 40% of the children on the merry-go-round go on the merry-go-round. So it says find the percentage of children on the Ferris wheel who will go on the merry-go-round the next time. So if you think about it, if you had 70%, if we go like, let's draw a diagram, and they ask us to do it in option C, question C. So let's just draw it anyway because it'll make our life easier. So let's go, we've got Ferris and then we've got merry-go-round. Okay. Now they said 70% of the Ferris wheel, I'll just underline it here, go to Ferris. So I'm going to write here, I'm going to have my little arrow. I've got 70% are going to do that. Okay. And then the other thing they told me was, 40% of the go to merry-go-round. So they've done that one, merry-go-round to merry-go-round. Okay. So let's just go back to this, the Ferris one. If 70% went back on the Ferris wheel, how many didn't go on the Ferris wheel? Who were there? 30. Good. So that means we know 30 went that way. Okay? So we write 30%. Then if we had 60% staying, 40% staying at merry-go-round, so how much is left of the ones at the merry-go-round? 60. So we would draw out there that 60% were going. So now we can sort of answer these questions again. So it said, find the percentage of children on the Ferris wheel that will go to the merry-go-round, and you told me that was 30%. And find the percentage of children at the merry that go to Ferris, which is 60%. Okay, so that was still a 2 by 2. Oh no, it asked me to construct a transition matrix for C. So sorry, let's do that. So we still got to construct a transition matrix. So if I write Ferris and Mary that way, I have to write Ferris and Mary going down that way. And then if I look, I've got Ferris to Ferris was 70. So I need to change that to a percentage. And Mary to Mary was 40. Now, I don't even need to look at my diagram because I know they add up to 1. I can change that to 0.3 and I can change that to 0.6 because it's a 2 by 2. There's only one bit missing. It has to be that. So you can look at that. So this is the transition matrix written out there. Okay. So this would tell us, in the end, we would use this to predict how many kids were going from ride to ride. So, it depends on what day. We say, all right, we've got 300. What's the pattern of this kids are going to do and things like that. But we'll do them in the future. Don't worry, we're just setting up transitions today. So let's have a look. An observant sales assistant noted that whether customers buy hot food or cold food in a store for lunch, they noticed that 80% of the customers who buy hot food will buy hot food again. So let's just do a diagram to help us. So we've got hot food and we've got cold food. So they just said 80% of hot go to hot. So arrow back to hot was 80%. And then they said 60% who buy cold have cold the next day. So 60%. So we can work out what that was. If 80% of going from hot to hot, how many left to go over to the cold? 20. Would that make sense? Mm-hmm. And then if 60 are going cold to cold, how many left to go back over to hot? Or 40%. Good. Okay, and it says construct a transition matrix. So when we draw the transition matrix, it's going to be a 2 by 2 because there's 2 options. I'm saying hot, cold first, hot, cold down that way. And then I add them in. So it's often easier to do the H to H and the cold to cold. And then I could look at my arrows, or I know they have to add up to 1. So I add in the next ones there. All right, so now we're going to applying the transition matrix. I'm going to pause it.